Welcome back. Now we're going to go into hypothesis testing. And we've been talking since the beginning of this class about statistical inference. And that's the process whereby we make a generalization about a population from sample data. And this is how we make decisions in statistics. Now, you might notice we haven't made a single decision yet, and this is the first way that we're going to learn how to do that. The other type of inference, called confidence intervals, we're going to get to a couple modules down the road. So, I want to give you a kind of general idea of what's going on with hypothesis testing. And we're going to see that we actually already performed a hypothesis test without even knowing it when we did the discussion boards on the error barometer. So, to start off with, we're going to have some sort of population we're interested in. And I'm going to choose a country. I might be interested in, say, in all the adult citizens of Morocco. And then I'm going to have some binary categorical variable. In other words, some variable that only can take on two values. And I might choose the question whether or not they have a smartphone or a cell phone. There'll be a category of interest. In other words, I'm interested in one of those two values, and most likely I'd be interested in if they did. And then we're going to have some population parameter. And in our case, we're going to limit ourselves to categorical variables. And so, if we think about it, what is a parameter? A parameter is the one number you would compute if you had all the values for that variable in the whole population. So if we think about this example with the error barometer, if I was an omniscient being and I knew every adult citizen of Morocco, whether they did or didn't, I had all the yeses and all the nos for that variable, what is the one thing I'd want to compute? I would want to compute the percentage of all Moroccans that were in my category of interest, that is, who had smartphones or cell phones. And so what you did here was you made a guess as to what the parameter value was in the discussion board. And so I might go ahead and I might guess that maybe 50% of the population has cell phones. And in a hypothesis test, what we're going to do is we're going to take that hypothesis or educated guess and we're going to test it. So I can test whether or not more than 50% of the population of Morocco has a smartphone or cell phone. And that's actually what you did. You made a guess, an educated guess, a hypothesis about what the value for this parameter was, and then you tested it. You took the actual data and you said, okay, estimates from a population where the percentage is, whatever you guessed, come from the central limit theorem, and you looked at the actual sample data and you said, how likely is it that I got a particular value? And this is the sort of logic we're going to use in hypothesis tests in this module. So one of the important things to understand about hypothesis tests is that they occur in a lot of different ways. And so I'm going to tell you the three main sort of scenarios in which you see hypothesis testing, and we're going to work through a sample problem from each. So the one sort of situation where we would want to do hypothesis testing is where some sort of change has occurred. And we want to see if that change has affected our population. So here's kind of an example that we might look at. We know that Florida repealed the mandatory helmet law for motorcyclists in 2000, and we're given the injury rate for 1999. And so the change that occurred was the law was repealed, and now we might be interested in seeing whether or not the percentage of people who were injured has changed also. So we could ask the question, is the percentage of motorcyclists that were injured in accidents after 2000, after the change, different than 80%? And we could test a lot of things. We could test to see if it was greater than 80%, but testing not equal is kind of a conservative type of hypothesis test. Who knows? Maybe the injury rate went up because the people weren't protected, okay, as far as their head goes, but it might have gone down. Maybe people drove more cautiously, okay? So we're going to test to see if there was a change in the population parameter. A very common use of hypothesis testing in business and industry is when we want to test a manufacturer's claim. So we're going to look at this famous ad that Colgate put out where they claim 4 out of 5 dentists recommend their toothpaste. Now, whenever we're testing a manufacturer's claim, we take the point of view that we're the consumer and we're testing against that claim. So we would be testing whether the percentage of dentists who recommend Colgate is less than 80%. We'd be testing to see if the claim was false. And the last sort of situation where we see this hypothesis test being used is when we want to test to see if a population has a certain property. So for example, in our discussion board about George Floyd, we talked about one property that humans can have, racism. And in the introductory video, we talked about a property that rats might have, which is empathy. And so we're going to actually look at this particular scenario, and we're going to ask the question, are rats empathetic? Now, empathy, like racism, is something that we cannot measure directly, so we need proxies. And if you recall the experiment that was done at the University of Chicago, which we showed in the introductory video, we saw the way that they measured empathy was whether or not a free rat let a caged rat go, open the door for them. So we're going to say that the population's empathetic when more than 50%, the majority of the population, exhibit empathetic behavior. And so we could test to see if the percentage of rats who open a door for a caged rat is greater than 50%. Okay. So the one thing that we have to understand that's a little tricky here is the logic underlying hypothesis test. What is it that we're doing? We have these 3 scenarios. They seem very different, but they're all actually doing the same thing. So the first thing you have to understand are the type of hypotheses we can have. And we can only have 2 for the sort of hypothesis test that we're doing. One hypothesis is going to be called the null hypothesis. And it's denoted by H sub 0. And the reason why is null means nothing, 0. And so I'm going to look at those 3 different scenarios that I just described, and we're going to talk about how we could interpret the null hypothesis. So when a change has occurred, the null hypothesis would say nothing happens. In other words, the parameter value stays the same. And since the injury rate was 80%, we would say that the population percentage after the change was still equal to 80%. No change had occurred. Nothing happened. With the claim, Colgate's claiming that 80% or more of the dentists are going to recommend their brand. So this would be the null. In other words, if that happened, nothing out of the ordinary would be said to have occurred. And finally, if we're looking at whether a population has a certain property, the assumption is that it does not have the property. Okay, so this is important. Empathy is something that you have to prove, right? Racism in a population is something that you have to prove. So the default assumption we make is that it doesn't have that property. And so here we would say that the rats were indifferent, it was 50%, or maybe they were actually anti-empathetic, right? Selfish, and it was less than 50%. And so sometimes people call the null hypothesis the no news hypothesis. It's the thing that if it happened, you wouldn't write a news story over. In other words, if motorcycle injury rates didn't change after the helmet law was repealed, we probably wouldn't write a news story. If we found out that Colgate's claim was true, we might not write a news story. If we found out rats weren't empathetic, we wouldn't write a news story because the null is kind of our default hypothesis. It's the thing we believe about the population parameter's value if we had no data. On the other hand, we have the alternative hypothesis. And the notation for the alternative is H, and the subscript here is either 1 or A. Our text uses 1. Sometimes I borrow problems from another book, so you may see H sub A, but it's easy to remember, A for alternative. And there's only 2. The null is always 0. And the alternative says, no, something new did happen. So let's go through all of these different scenarios. And the key thing to understand, and this is the most important thing about the alternative is the thing we're trying to prove. That's the important thing. People used to call the alternative hypothesis, if you read old statistics articles, they used to call the alternative the research hypothesis. And I love that name because the alternative hypothesis is the research question we're trying to answer. Okay, so let's look at the 3 different scenarios. So if we're looking to see if a change occurred after the population, the alternative would say, yes, it did. Or in other words, the percentage wasn't equal to 80%. If we're testing the manufacturer's claim, it would be that the manufacturer didn't meet the claim, which would be that the percentage of dentists who recommended Colgate was less than 80%. Something new happened, right? If we're looking at the population having a new property, remember, this is what we're trying to prove. So we're trying to show that they're empathetic, or in other words, the population percentage is going to be greater than 50%. Now, I want to show you something to kind of help you a little bit. Notice that whenever we're working on a problem, one of the first things we want to do is we want to kind of sketch out the problem. The first thing we want to do is we want to understand the parameter, the variable, and the population. And let me actually take you back one slide right here. Okay, this is what we want to do. When you're lost on a problem, and this happens easily as a student, and even myself, when I read research statements, I sometimes have to kind of puzzle through them. Identifying the parameter first, then the variable, then the population will always help you get your bearings and understand what's going on. Okay. So what I want to do next is I want to go through how a hypothesis test works. What are the general steps? Remember, we said statistics is a rational process, okay? And it turns out that a hypothesis test is actually a very general term. It actually comes not from statistics. It comes from a branch of philosophy called epistemology, which is the study of how we know what we know. And a hypothesis test is a test in a belief about something. It could be a belief in the value of the parameter, which is what we're going to do here. It could be the belief in, a God, okay? It could be a belief in a lot of different things. But what we're going to do is we're going to find that statistical hypothesis tests are very similar to the process that goes on in a court trial. So the first step we always do in a hypothesis test is we state our hypotheses. And what is the very first thing you do when you go into a courtroom? The judge asks, how do you plead? And just like there are 2 pleas, there are 2 hypotheses. The null says nothing happened. It's the thing we would believe if we didn't do the study, our default belief. The defendant's equivalent of a null hypothesis is not guilty. It says nothing happened. I didn't do it. And again, it's what we would believe. It's what we start off believing in the absence of any evidence. If the prosecutor comes in and says, I have nothing today, the defendant walks out of court a free person 100% of the time. The key thing to understand understand about the null hypothesis, it is our initial belief in the value of the parameter. And that initial belief can come from historical data we have in the past. It could come from a common sense notion, like what is the probability I'm going to get heads if I flip a coin? We would initially assume it's 50% until we had evidence to the contrary, or things of that nature. Now the alternative. Again, alternative says something happened. It's what we're trying to prove with our data. Okay. And of course, what we're trying to prove in a court trial is that the person's guilty. So the prosecutor takes the equivalent of the alternative hypothesis here. Okay, now what do we do next? Well, first we look at our data. We make sure that it satisfies the central limit theorem, and then we compute our sample estimate. And in the context of a court trial, we're going to think of data as like evidence. It's important to understand the data is always in favor of the alternative. Just like in order to bring you into court, and for example, to hold you to put you on trial for, say, something like a capital crime like murder, there has to be some evidence, right? There has to be a grand jury that indicts you. There has to be some evidence. So there's always evidence in favor of the alternative. The question is there enough? The same way that we know in a criminal trial, there's some evidence, but is there enough to prove the prosecutor's case? What is the equivalent of that in a court trial? Well, evidence is presented, just like we compute our sample estimate, and we make sure that it's admissible, which is the equivalent of checking the central limit theorem conditions. If the evidence is not collected properly, in the same way that if the data is not collected properly, what happens? The whole trial is thrown out, or at least that evidence is thrown out, right? And if the trial depends on the evidence, then the whole trial is thrown out. The same thing is true here. If the data doesn't satisfy the central limit theorem, it's considered not to be admissible, and we can't use it. And without the sample estimate, we have no case. So what do? We have to shut down the whole hypothesis test. We cannot make decisions based on bad data. Just that simple. Okay, now the next step has no analog in a court trial. What we do is we find the population of estimators that we would get if the null hypothesis is true. It's important to understand that when you're doing a hypothesis test, you always assume the null is true. And the point is that we know the value of the population parameter if the null hypothesis is true. And so we can ask ourselves, what do estimators from the population look like if the null hypothesis is true? And that's what we want, because that's what we're going to use to judge our sample estimate. Now, there's no analog of this in a court trial, but we're going to see that the calculus or the logic of how jurors make their decision is very much similar to what we're doing in a hypothesis test. So the next step is, now we have our evidence. Okay? We know what a person would look like if they were innocent, if they came from the null distribution. So now what we do is we judge the evidence relative to population of innocent people, or the population of estimators we would get if the null hypothesis was true. So what we do is we take our sample estimator and we determine its percentile in the population of estimators we would get if the null hypothesis was true. And what we ask is, if the null is true, how likely is it we could get our observed sample estimate? In other words, how likely is it that our observed sample estimate looks like it comes from the population of estimates we would get if the null was true? We're seeing where our estimate stands relative to the other estimators we'd get if the null was true. And in a court trial, they do the same sort of thing, although it's not quite as quantitative and precise. What the jury is asking, They have all this evidence against the defendant, right? And they're asking if the person was innocent. Okay? In other words, if the null is true, how likely is it we could get all this evidence against them? Okay, now what do? We've weighed the evidence, now we make a decision. So the way we make our decision is we say if it's too unlikely, this sample estimate could come from the population of estimates we would get if the null was true, we reject the null hypothesis. And if there's some evidence, okay, but it's not that unlikely that our sample estimate could come from the population of estimators if the null was true, then we fail to reject the null. And again, this is similar to what goes on in a court trial. If it's too unlikely, we could get all this evidence against a defendant. If they're not guilty, we find them guilty. And if there's some evidence, but it's not enough, we find them not guilty. And so this is kind of the logic of how a hypothesis test works. And in the next video, we're going to start looking at this first step of how we form the hypothesis. And then in each of the subsequent videos, we're going to look at how we do those steps also. All right, thank you.